A very good morning to our lecturer and my fellow friends. I am from Group 9, Section 9, and my name is Jaswin Murigia, and are my group members. Our project title is Enhance Peat Soil in Developing Regions by Using Several Methods. For introduction, peat soil defined as a type of soil which is made from over thousands of year decomposed material and mineral substance. Normally, peat soil accumulate in wetland ecosystem which are called peatlands or peat bogs. Peat soil is an essential ecosystem that gives us a significant contribute to the global climate stability. Even though the utilization of peatland is low, the demand has been rapidly increasing despite of the population growth and various economic reasons. Civil engineers often prefer to avoid earth construction on peatland. On the other hand, peat soil is often considered a poor quality of soil for the construction due to its low shear strength, poor compressibility, and high groundwater content. Peat soil is considered as a problematic soil due to the natural properties of low shear strength, high compressibility, and high initial water content. It is suitable for plantation and agriculture purpose, but when it comes to construction field, it became unsuitable and unfavorable for the engineer to construct the structure like road, building and foundation on it. Therefore, this paper was aimed to evaluate the strength of peat soil which was stabilized with several methods such as ordinary Portland cement as a admixture and more. This project was conducted to determine how unstabilized peat soil behave physically and chemically on the construction land. Apart from that, this study also aimed to determine the strength of efficiency of stabilizer combined with peat soil. In construction industry, OPC is always the first choice cementation material for the cement column stabilization because it's economically friendly and high accessibility.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fahmi, and now I will present about physical characteristic of peatland soil. And for water content when saturated, fibric peat have a greater capacity to retain water than hemic and sepric peat, which are less than. For moisture content in the field capacity, fibric peat can contain more water than hemic and sepric peats, which were previously studied. For bulk density, a peat sample from the Serbangau and Durian Rasau area of West Kalimantan, Indonesia were analyzed for BD and found to vary between 0.09 and 0.23 gram centimeter cubic. Next, for chemical characteristic of peatland, reaction of peat soil, the higher the mineral concentration, the more fruitful the soil is in peatlands that frequently overflow. And for the electrical conductivity, in tidal land, high level of natrium in the soil are an indication of soil salinity caused by exposure to seawater, according to the result of a peat soil analysis. Next, I will present about stabilization using lime and cement. Soil improvement include both stabilization and change of the soil. Solvent addition, such as lime and cement, are used to change the soil's index properties, while treatment to improve the texture, strength, and CDR value of soil are used to ensure that the soils are long-term construction ready and have no shrink well or other undesirable features. Deep in situ mixing method or surface stabilizer are both possible uses for this chemical admixture. Next, for the explanation of lime, when lime is added to the peat soil, it reduces its optimum water content and increases its maximum dry density. In addition to stabilizing weed fly ash to reduce settlement and boost bearing capacity, lime was also commonly utilized to stabilize it. Stabilization procedures that use cement are most frequent in soil treatment. Next, for the soil stabilization in peat soil had the lowest shear strength because it is so soft and had such a large amount of organic material. The soil will be stabilized more effectively by employing lime and cement as an additive. Stabilizers such as lime and cement have a chemical reaction with soil element in the presence of water and the percentage of stabilizer agent. Lime concentration, short-term response, and soil mineralogy all play a role in lime-treated soil performance. The superstructure will be less damaged and destroyed if organic soil is stabilized with lime and cement. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh and good day. My name is Muhammad Shukri bin Jalal. I'll be presenting about methods to improve the strength of peat soil other than OPC. For the second method is by using gypsum and fly ash as additive. Firstly, we must know how to conduct the mixture of gypsum and fly ash. To conduct it, pit soil must be sieved with a mesh size of 2 mm. The fly ash and synthetic gypsum additions were oven dried overnight before being cooled to room temperature and stored in a desiccator. The treated sample were made by dry mixing pit soil with various percentage of synthetic gypsum, which is 0% to 20% the dry mass of the pit soil. Then, it is being mixed with 10% of fly ash. Then, the sample being cured for a week in the airtight container. The reason the soils were added with synthetic gypsum and fly ash is to know the effect of synthetic gypsum with the adjusted amount of fly ash on the geotechnical parameter of the pit soil. Then, for the next method, which is bicarbonate precipitation method. The materials used for carbonate precipitation method are urea, calcium, magnesium sulfate heptahydrate with the purity of 99.5%, urease enzymes, hydrochloric acid, and pit soil. Both urea and calcium chloride have a purity of 95%. Then, to conduct the carbonate precipitation method, a few methods need to be conducted, which are precipitation test, pit soil preparation to conduct the unconfined compression test. So, I think that's all from me. Thank you.
Assalamualaikum. My name is Muhammad Haji Fahmi bin Zainuddin. I will be presenting about application of ordinary Portland cement as binding agent to stabilizing pit soil. This topic discuss about laboratory study on stabilizing pit soil using ordinary Portland cement as binding agent. Due to pit soil sample had a high beginning water content, using ordinary Portland cement as binding agent can reduce the weight of water weight of cement and the stabilized pit soil hardness and acquired strength. To determine the strength value of both the undisturbed pit soil and stabilized pit soil, several tests has been conducted. Those experiments known as unconfined compressive stress (UCS) and California bearing ratio (CBR). The sample of stabilized pit soil used for the UCS and CBR test were at their natural moisture level, so no water was added or taken away from the pit soil when it was mixed with cement. Unconfined compressive stress (UCS). The objective of unconfined compressive stress test is to determine the unconfined compressive strength of the soil. The test is used to provide an approximate of soil strength and decide viable building strategies. The test is utilized in all geotechnical engineering design and stability analysis of foundation, retaining wall, slope, and embankment. Result of UCS soaking test. Figures show that the addition of ordinary Portland cement (OPC) with different percent, that is 15, 30, and 50% to pit soil result in an increase in UCS value. For stabilized pit soil sample, UCS value increase as curing time rise and unconfined compressive strength of the soil value rise as addition of ordinary Portland cement (OPC) increases. That's all from me. Thank you.
Assalamualaikum. My name is Adik Fanakuddin bin Abu Bakar, and now I will explain for the California bearing ratio test, which is also known as CBR test. The purpose of CBR test is to make sure the California bearing ratio by the utilization of a load penetration test that is carried out in the lab. The document that been used is the BS 1377 Part 9 1990, an arbitrary strength test that will simulate wheel load. The California Highway Department was the first one developed it. For the experiment, sample of stabilized pit soil with OPC were made. Stabilized pit sample will cure for 90 days, and the CBR test was done before and after soaking on stabilized pit sample. Next, I will explain for the result of CBR test. The figure below shows CBR test result on stabilized pit soil sample using OPC after 90 days of air curing. The CBR value improved with more cement in the mixture. Soaked sample have lower CBR value than unsoaked sample. The general rating of the in situ pit soil will improve from extremely bad to fair and good with the use of the air curing technique and OPC of the pit soil stabilization. Next, I will explain for the procedure of the CBR test. First, put the mold with the sample base plate in the middle of the lower platen of the testing machine. Next, set annular. Suggest this on top of the sample. Next, put the plugger and the device for measuring force on the sample. The fifth step is write down the reading from the force measuring device as the original zero reading. The sixth step is start the test so that the plunger goes into the sample at a rate of 10.2 mm per minute and start the timer. The seventh step is write down the reading from the force gauge every 0.25 mm up to a total penetration of 7.5 mm. The last step is remove the base plate from the bottom of the mold, then flip it. If required, trim the surface. If the sample is to be soaked, use the right perforated base plate. That's all from me. Thank you.
For conclusion part, there was a major problem was found on the stability of development on pit is mostly consequent from settlement leading to failure. There was a several reason why buildings in pit soil are often affected by stability due to the low strength, poor compressibility and high groundwater content in pit soil. These territories cause bearing capacity failure and make large deformation. Several methods such as soil stabilization, pre-loading, vertical drain, prefabricated vertical drain, deep stabilization method, and cut carbonate precipitation method and fill or replacement had been introduced by previous researchers in order to improve peat soil in construction areas. However, a lot of research approached a lot of methods, but some of them require huge amount of budget and yet the effectiveness of the ground improvement method is questionable. Hence, ordinary Portland cement consists of mixture of cement and lime with soft or weak soil to stabilize the soil has been evaluated which is environmentally friendly, less cost, effectiveness, reliability and durability. This study also revealed that the compression strength of the soil is found to increase significantly when lime and cement content were increased and OPC as a grade resistant to cracking and shrinkage. For recommendation, in future research should focus on the development of peat for agriculture soil improvement. In modern agriculture, the problem of soil fertility decline, environmental pollution and crop quality decline caused by the unbalanced fertilization and excessive chemicals should be focused. The research about effectiveness of peat soil can be conducted into five aspects such as power fuel, agriculture utilization, chemical technology, and medical and environmental protection. That's all from me. Thank you.